In terms of the drilling from the top, we also did on all the underground workings. So we cut pieces through it. It's almost a small little drill hole that goes from the granites through the reef zone here and back into the granites. And we would sample 50 centimeter samples into the granite and into the granite so that we get the whole intersection.
Yes, we're on 3 level, that's 300 feet below surface. And what you're looking at here is very special. This is a reef of monazite ore. Monazite is a mineral that contains rare earths and a few other things. And here, as you can see, there's been a lot of sampling done. And these samples show that what you're looking at here is very special. This rock here contains about 30% rare earths. It varies between 20 and 40, but this is an extremely high rare earth occurrence. And Steenkampskraal is mainly this small but very high grade rare earth occurrence. In areas like this, we will drill holes in, put dynamite in, very old-fashioned conventional mining, blast, and then there'll be a pile of broken rock here. The broken rock will be trammed in cocoa pans along to the bottom of the shaft where we walk down, and it will be hoisted up to the top using the headgear and the winder house that you saw. And there it will be put into the concentration plant. Now, although this is very high grade, at 30% on average in this particular zone, it does mean that about 70% of the rock is waste. So we have to concentrate the ore. So there will be a series of procedures to make a monazite concentrate, which will be about 90% monazite, nearly 60% rare earths. So that is the first operation that we will do, is to concentrate the rare earths. This ore contains rare earths and thorium. Thorium is a radioactive material that we must remove from the rare earths before we can sell the rare earths. Cerium is very cheap, $2 a kilo. So not all rare earths are rare, some are quite abundant, and cerium is the most abundant of all. And its main application is glass polishing powders. So it's used in glass factories to give a very shiny, smooth surface to glass. It's a huge industry and they use thousands of tons of cerium, but as I said, it's quite cheap. The second most abundant is lanthanum. And lanthanum is used, the main thing is in petroleum refineries. It's used as a catalyst to separate crude oil into the various fractions, like petrol, diesel, aviation spirit, and many other products. Then we move into neodymium, which is the third most important. And neodymium, the very, very important new use is in the electric motors for electric cars. The initial planned production rate is quite small at 2,700 tons per year, but that's what we can mine using the existing infrastructure that you can see, using the existing shaft. At a later stage, depending on the market and prices, we could double production and then double again. But initially it'll be 2,700 tons per year. There is such a thing as a weighted average basket price. I mentioned that the cerium price is $2 a kilo, but there are other rare earths that are $200 a kilo and even more. So the weighted average basket price that we're looking at now is just below $20 a kilo. So 2,700 tons a year, multiply that by $20 a kilo, 2,700,000 kilos. So anybody can work that out. The important thing for us is not so much the volume. We don't try to pretend to be a huge operation, but rather a small, high-quality one. And in view of the fact that so much infrastructure is already here, so we don't have to spend a lot of money digging shafts and digging and preparing the stopes. And due to the fact that this grade is so high, we only have to take out a small amount of rock to produce our 2,700 tons per year. So we expect to have a very, very low production cost. We think our cost will be below $10 a kilo, with prices of about 20.